Okay, so for this next problem, we have to write the equation for the tangent line using this function when x equals 0. And then we have to use t of x to find the differential. So for the first part, to find the equation, we're going to use this, f of c plus f derivative of c times x minus c. So since c actually means x, we're going to plug in 0 wherever it says c. So f of 0 plus f derivative of 0 times x minus 0. So to plug in the values for this, we're going to take f of 0 and f derivative of 0 and plug it in back in the original. So when you plug in f of 0 in the original, we're going to get 2. Then to find f derivative of 0, we have to take the derivative of the equation, which would end up being negative 1 over 3 times the cubed root of 8 minus x squared. So when we plug in 0 for there, we're going to end up getting 1/6. So since we know these values, we can plug it back in. So t of x equals 2, because that's what we got when we plugged it in, plus a negative 1/6 times x minus 0, because c is still 0. So when we're going to distribute this, we're just going to get negative x plus 0. So we're going to get 2 minus, because this is a negative, 1/6 x, and that is going to be the equation. Now, to find the differential, we're going to change the equation so that it looks like this, because in reality, we're trying to find the difference. So the cubed root of x is what we're going to use as our function. X is going to equal 8, and then h is going to equal negative 0.05. So this is what we're going to plug it all back into. So f of x plus h, f derivative of x. So f of 8 plus h is the same thing as it was, negative 0.05 times the f derivative of 8. So when we take the derivative, that really equals x to the 1/3, and then we take the derivative, and it's going to be 1/3 times cubed root of x squared. So when we plug in 8 to the original equation, we're just going to get 2 plus negative 0.07 times, and when we plug in 8 to the derivative, we're going to get 1 over 27. So when we plug that all in to our calculator, we're going to get 1.998. Okay, next question. For the next question, we have a rectangle on the x-axis. We don't know the lengths of the sides, so we're gonna, since it's the same length for when it's cut in half by the y-axis, it's the same length on each side, so we're gonna use x. And the parabola is touching its vertices in the corner right here, and the equation of the parabola is y equals 12 minus x squared. So we know that the area is length times width. So this is the length, and this is the width. So actually, our length is 2x, and our width would be the equation of the parabola right here. So when we multiply those together, we're going to get 24x minus 2x cubed. So what we're going to do from there is take the derivative. We're going to get 24 minus 6x squared and equal the derivative to 0 so we can find x. So when we solve, we take the 6 to the other side. So everything's positive. We divide by 6. We get 4, take the square root, so x equals positive negative 2. And then from there, we're going to plug x back into the area formula. So 2 times 2 times 12 minus 4. So we're going to get 4 from here, and then 8. So the total area is going to be 32. And our dimensions are going to be 2x times 12 minus x squared.